All right, chemistry crew, we left off with our ballon, and let's get through the last few pieces of equipment. I set a timer for myself here so I get this moving. Okay, so we are up to graduated cylinder, which you know. Graduated cylinder. Okay, graduated. Let's explain that one. So, actually, that has graduations. So does this, and so does this flask. So the beaker, the graduated cylinder, and the flask all have graduations. Did they graduate? No, they did not go to school. Graduations means that there are markings, there are lines for measurement. They're called, it's like a gradient. If you took earth science, you know how things, like, you could measure different, like, elevations. Those are gradients. So that's really what they mean by that, is that there are measurement lines. There are gradients. Now, here's the thing. Yeah, the flask and the beaker have gradients, but these things are not that well made. They're not really for measuring. However, graduated cylinders are, if you know how to read them properly, they are actually considered quite accurate. So, graduated cylinders are for accurately measuring the volume of a liquid. That's what you're going to write down. You do not use the lines on a beaker or a flask for measuring. That's really for, like, guesstimating. It's like if you don't really need a specific amount and you're like, I need about 100 milliliters of water, cool. But if you really want to know that you have 7 milliliters of something, or well, in this case, I poured over 7. Trying to get the bubble out. Really quick, we'll study this more in the future, but there's something you need to remember about graduated cylinders. The water is attracted to the glass and makes a curve called a meniscus, right? So here's what you have to remember about graduated cylinders. I can't really draw, so I'll try this. The water makes this sort of like a curve. You have to read, I'm going to try to draw an eye here. You're going to read from the bottom of that curve. I know it's a little tricky, but when you have any sort of glass container, you're going to notice that the water molecules crawl up the glass. Why? We'll learn about that later. But when you are reading a graduated cylinder, what you want to do is kind of really get in there, close one eye, and look across to see the bottom of that curve. So that's an important thing to remember. But there we go. So graduated cylinders are for accurately measuring the volume of a liquid, and you just make a note to yourself, you have to read from the bottom of that curve. Okay. Next, tongues. Not thongs, tongues. This one's easy. Let me get rid of this guy. I'll leave my cool picture there. Is it a cool picture? I don't think so. Anyway, tongues. This is easy. These are also, you know, kind of in the kitchen, except you wouldn't want to touch these to your food. So there's different types of tongs. This type, you squeeze it, it opens, you put it over the test tube and you let go. And the trick here, which I've seen people mess up really badly, is don't squeeze it while you have a test tube there because it falls out. So this is called a test tube tongue. Take a wild guess why you may want to be using a test tube tongue. And this is just water, but I really, before I do anything, really should have, especially before turning any fire on, just in case of an explosion, should always have goggles on. So the reason why we're going to be using tongues is, of course, because we're going to be heating things up. Okay? So this is Test tube tongue. Remember, you do not squeeze it again. Crucible tongues. Again, crucibles are going to be heated till they're at extremely high temperatures, so never grab a crucible or the lid without using crucible tongues. These are brass tongues, all right? I've seen people get hurt on crucibles because they grab with their hands. Always do this. I know that the crucible tongues have that spot in the center. Honestly, I always drop crucibles like that. Just pinch the side. That's what I like to do. Okay? And also, let's say we were just heating something up. All right? These are called beaker tongues. They can work on a flask, but because the flask is shaped like a funnel, it doesn't work that well. But these are beaker tongues, again, for grabbing hot stuff. So basically, the different types of tongues are for grabbing hot pieces of equipment, okay? So be very mindful of that. Most of the time, people get hurt in chem labs, it is from heat burns. Okay. Next, let me move some of this stuff out of the way. And by the way, on the lab, you should be seeing images next to the lines. So when you notice the pieces of equipment, you should be looking at what they look like. All right, so this thing is called a Buret. Okay, a Buret kind of has a similar situation to the graduated cylinders, where when you pour water inside of it, you're going to notice the water get attracted to the glass, and it's going to make a curve. So we're going to see that happen also here. So now the Buret, let me show you. I'm going to fill it up a little bit. Okay, so Burets have measurement markings on them, so you can read the volume of liquid. Again, you got to look at the bottom of the curve. And what Burets are for is carefully adding Burets are for carefully adding an amount of liquid and measuring accurately. So let me say that again. Burets are for accurately adding certain volumes of liquid. So I'll show you why that's the case. Instead of like going, oh, I don't know how much of this, and just going like, and pouring a bunch of stuff, if you want to do a chemical reaction carefully, I'll show you how a Buret works. It's basically like a really slow faucet. So what you would do is read the markings on the side, right? Look at the bottom of the curve of the liquid, write down how much, and then what you do is you turn this, and of course, what you do is you add liquid until, and when chemists use these, we'll see in the future, you're usually watching a chemical reaction happen. So usually some sort of a color change. And when you notice that the chemical reaction occurred, what you'll do is turn this off, although I totally messed up really bad just there. I'd have to redo that experiment because I just got some dripping outside, which means that when I go to read this again to see how much of the chemical I added, my measurement will be incorrect. So I screwed up a little bit, so I'd have to redo it and dump this. But anyway, so a Buret is for, it basically allows you to add very precise amounts of a liquid, okay? Because you can really get this thing. Actually, if you're careful, you can get it to add a single drop. I actually just got it to give me, one drop. And you just saw another thing to be careful of. You don't want to break the tip there. Okay, so Burets are for adding and measuring small amounts of liquid and adding them together. Okay, that's the Buret. All right, next. I love these guys, and they don't look like much. These are called watch glasses because they resemble the glass on the cover of a watch. So these dudes are actually very useful. So watch glass. So what can this boring piece of glass do? Actually, it can do a lot of stuff for us. So let's say we're heating something up in a beaker. It's unplugged, but let's say we're heating something up and it's like cooking rice in the kitchen. We don't want too much water to evaporate. We can use that as a lid. Let's say we want the hot steam to heat up a chemical without, making it catch fire. What we could do is add the chemical on top of the watch glass, let the steam heat it up. So watch glasses can be used for evaporating. They're also called evaporation dishes. Well, that's a separate thing, but you could use them for evaporating things on. As you can see, another use of watch glasses is as a lid. So we could use them as a lid. We could use them to evaporate things off of. We could use them to, if we wanted to, we could technically put two chemicals together and mix them on there and watch what happens because it's clear. So yeah, watch glasses are good for using as a cover, for evaporating things, sometimes for watching chemical reactions, and you could technically even heat something up on top of there. Okay, so that's the watch glasses. Okay, I'll do one more and then I'll make one last video because I don't want to do too much at once in one shot. Okay, so one more thing for this video is this guy, which you've probably seen in movies. This is a condenser apparatus. So I don't have it hooked up properly. A condenser, well, it does what the name says. To condense is when you have a hot gas and you cool it off and turn it into a liquid. So a condenser allows us to turn something that is a gas and cool it off back into a liquid. The way that that works is, I'll turn this sideways a little. You're supposed to use this near a sink, and you take a rubber hose and you have cold water fill up this inner part, and then the water drips out the bottom. So now you have a layer of cold water cooling off the glass, and then what you would do is, let's say you were boiling something here, you'd hook it up to the top so the hot gas comes in, touches the glass that's getting cooled off, and then it turns back to liquid and you get a liquid out. So a condenser is for cooling off a gas and turning it back into a liquid. That's literally the definition of condensation. That's condensation. Okay? When you see your breath, the water in your breath is a gas, and then it cools off and turns back to liquid. Okay, that's condensation. So that is a condenser. Okay. Let me step over here, see if you can see that. All right, next video.